Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is going to be about SocketServer and Socket, and basically part one. It's picking up from the introduction. Let's go and open up my web browser to my website, javacjava.com, select Java Tutorials. I'm going to scroll all the way down here to the ServerSocket and Socket Part 1. So in this tutorial I will continue expanding on concepts from my ServerSocket and Socket Introduction. I'm going to create a ServerSocket prime number calculator application that communicates over port 4141. The ServerSocket will listen for the incoming client connections to provide a number, then the server will respond back with prime, composite, or invalid number. Now, in addition to that, I'm going to throw a little bonus knowledge in on how part of the underlying transmission control protocol / internet protocol, which is TCP/IP, actually functions. TCP/IP was created way back in the 70s and has slowly evolved into the dominant method of transferring data. Now, there are three things I'm going to go over in this video. SYN, which is short for Synchronize, ACK, which is acknowledge, and actually this should just be FIN here, but that's final. And they form the basis for establishing socket communications and terminating socket communications. So let's go ahead and get started. I'm going to go ahead and move this off screen here. Let's go and open up our command prompt. If you don't have one, you can create one really fast by right-clicking, selecting New, shortcut, CMD, Next, and Finish. It's just that easy. We'll go ahead and open that up. Type in CD space / to move us to the root. CD Java. I already have, actually, you know what? Let's go back again here. Make dir Java, right? I already have that folder, but if you don't, it'll create it for you. Now let's change directories to the Java folder. I'm going to make a directory here called Sockets1. Okay, let's change directory to that Sockets1 folder. And I'm going to notepad server.java first. Okay, we're going to create two files today, server.java and client.java. Okay. So in the server.java here, we'll just come over here and scroll down here. Cut. Actually copy, and we'll come over here and paste that. Okay, well, let's come up here and save this. And you know what we'll do is we'll run it first, and then I'll go back and explain everything here. So we'll go ahead and save this, minimize that. Let's go ahead and compile it. And let's go ahead and run it. Okay, so it's listening on port 4041. Control C to quit. We're going to go ahead and open up another command prompt here. And we're going to change directories to that Java and to the Sockets1 folder. And now we're going to notepad client.java. Okay? Let's come over here back to the website. Let's come down to the client Java section here. Let's copy and paste all that stuff there. All right, and once again, I'm not going to go over anything yet. We'll just run this real quick there, and then I'll go over all the source code and how it all works. So let's go ahead and Java C, compile that. Java client. Now the first thing I'm going to do is just type in Java client. It's going to come back, must include a number as a command line argument. So let's please try again. Okay, so what I'm going to do is I'm going to take this one over here and kind of put it into a smaller window. And then over here we'll go ahead and do Java client, and for example we'll just put in 13 as a prime number, right? So we're going to get a whole bunch of stuff over here. We got our answer equals prime, and we got some received and sending stuff over here. Okay, so now I'm going to pop back first of all to the server Java here. So we're importing the Java IO package and net package here. Here's the main method entry point. There is two other methods here, the write method and the CowPrime method. Now the CowPrime method is basically taking in the string input that we put in there and calculating and returning it back. Let's come back over here, and the first statement that I've got is I'm creating an object of type server, which is my class here, right? And then I've got this try statement here. So this try statement is try with resources, as you can see. And I am basically creating a socket server object listening on port 4141, okay? And it's just catching IO exception, and of course, because it's try with resources, that'll go ahead and invoke the, the closing stuff and all that to clean it all up while it's done. All right, then I've got this this infinite loop here, while true, right, which ends right down there. And basically, we'll be accepting socket connections, and then we'll close the socket connections. But of course, we always want to, after we've closed the socket connection, we want to start back up and listening again. So that's why it's always going to be looping at true. The first thing it does is displays this, listening on port 4141, right? That's this one right over here, right? Listening on port 4141, control C to quit. And get this out of the way. All right, so now I run the socket server accept. If you remember from my last tutorial, this particular accept method blocks. So it sits there and waits, right? Which is what it's doing right now. It's just sitting there blocking, waiting for a connection to come in. Now over here, right, let's kind of go back over to, and we're going to leave this right at this point over here on the server end, and now talk about what happens over here on the client end when we fire this up here. Okay, so the client class here basically has the main method entry point and then a simple little write method down here. So coming right in, we're just checking to see if the command line arguments, if it's not equal to 1, must include a number. You saw that, and we return. Okay. I'm creating a new client object, right, which is the same class here. Okay. And now you want to change your server's IP address here, right, to whatever your IP address is. And if you've forgotten how to do that, right, you can simply type in ipconfig, right, and you're looking for basically your local network address, or if you're connected through the Ethernet there, or not Ethernet, Wi-Fi. But basically, you're looking for your local address of your computer right here. It's ifconfig if you're running Linux there. So. I believe in Apple too, it's ifconfig. But anyway, so plug that in, change that to whatever yours is here. So, and I'm using try with resources again right here, which will close everything out, and it's catching IO exception as well. Now, if you've never seen this before, you probably are like going, what? But you can actually stick multiple statements inside of the parentheses for the try when you're doing try with resources. All of these classes, the socket class, the print writer, and the buffered reader, they all implement auto closable, so you can just stick them all in here and execute them line by line by line. So the first line statement I should say that we're executing is creating this new socket reference to this socket object of the IP address over 4141. Okay. So what that does, when that invokes, when this line executes right here, if we pop back over to the server Java class right here, that causes accept to go ahead and move on, okay? So now, using that same try with resources syntax, try catch with resources syntax here, I'm creating a print writer output, right? And this uses the socket object and invokes the getStream method on it. Get output stream method on it there, right? There's two of them that we're interested in, the socket get output stream method and the socket get input stream method. Output writes to the open socket, input reads from the open socket. Excuse me. So we got our output object right here, and then we've got a buffered reader input object that basically takes an input stream reader, and if you've watched my tutorials, you know what that is there. But anyway, so when we see this connection accepted there, I'm just going to display to the console connection accepted. And if we come back up here, right? Oh, wait, that's the client end, right? The server end, we got this connection accepted right there, okay? And now once we've got our connection accepted, I've just got this string variable in that just basically serves as like just takes all the input buffer and holds it in that variable there. So now I'm going to loop, and while we're constantly reading the line there, right, while it's not equal to null, right, I'm just basically setting into that there, right? So as we get new stuff come across there, it will go ahead and execute inside this while statement there. So the first thing that we send over here on the client end is we connect our socket. We of course have our same output and input buffers going there, right? And we write to the output SYN, okay? And this write method down here just basically takes the print writer output reference there and the message. And we display that to the console, and then we go ahead and invoke the print line method from the print writer class up here on this output reference variable. So we write the output to the console, okay? And TCP, TCP protocol, well, that's redundant, but TCP basically, when you start the handshake, the first thing the client does is it sends to the server this SYN. Okay, so over here, you can see I'm sending SYN, okay? Now, the server then, I've got it in its own loop over here, and it inputs and it says received. And now, if we come over here, we got received SYN. So in my little if statements, and this is basically my protocol here, and that'll make more sense in future tutorials on what this is, but it's a very primitive protocol. So, and our in equals SYN, which means synchronize. So the client says, okay, let's go ahead and send the synchronize command, right? And then the server writes back in its output there. The write is the same thing as, same exact method as it's over in the client there. It says SYN-ACK, which is synchronize. Hey, I'm acknowledging that you want to synchronize, okay? So from the server's end over there, it received the SYN, and it's sending back synchronize acknowledge. And then on the client end there, it received synchronized acknowledge, and then it went ahead and checks for that, synchronize acknowledge, and then it writes back out, okay, I acknowledge that, right? So it's like, you know, an old CB thing like copy, you know, 10.4, blah, blah, blah type stuff there. So it writes back out, I acknowledge that, you acknowledge that we're synchronized. So now we're ready to communicate, essentially. And is this necessary at this high level? No, but this is actually what goes on in the TCP when the actual connections make, when it actually connects up through the socket connections there. Okay, so I just thought I'd put it at a high level so you guys can kind of learn what's going on there. Plus you get to see it working too. So it sends back over here. We're on the client end, so it sends ACK, right? And this received ACK, and now we're going to go ahead and send back over here to the client. We're going to send our number, right? So we're going to write to the output there. We're going to say number equals, and then plus the argument that we took in, which is the arg from up here in the main method, obviously. And so it writes that. So back over here to the server I've got in my while loop, I've got if the input basically contains number equals, right? Then we're going to go ahead and write back the result of the CowPrime method. And we're passing in basically number equals. In this particular case there, it's sending number equals 13, right? So this value that we take into the CowPrime method will be number equals 13. The CowPrime method is pretty primitive. It's not the most efficient way to calculate a prime, but it gets the job done without a whole lot of explanation or adding in a whole lot of overhead there. Int I is just basically setting that up for the what we're going to parse the int to, right? So using the integer class, right, and invoking the parse int method there, right, we can pass in a string value. Basically the substring of 7 is taking, the format is coming in as number equals, so we're cutting off the number equals, right? And then we're taking whatever's left after that. Now, the integer class, of course, throws a number format exception if this string that comes in cannot be parsed, right? So if somebody throws in, for example, like number equals ABCD, right? It's going to throw this number format exception and return answer equals invalid number. Okay. Otherwise, we're just basically starting x off at 2, and we're saying, well, 2 is less than, for example, this was 13, right? We're just going to say if I, which is our integer, which is 13, and then modulus basically is the remainder. 2, this starts off with 2. 13 mod 2, is there any remainder if we take 13 divided by 2? No, that does not equal 0, right? If it does, if a number divided by another number equals 0, that means it's evenly divisible, and which means it's a composite number, not a prime number. So that's basically how this works. But don't worry about that. Just know that it works, and if that's confusing, move on. So then we respond. So we come back up here, and we write to our output number equals, okay? And so you can see over there, receive number 13, sending answer equals prime, okay? Now, coming back over here, we got received answer equals prime. And if we look at, we come back in here to the client thing here, right? I've got if the in contains answer equals, right? Then I'm going, the input here, right? Then I'm going to send to the server basically fin, which means final. So that means I'm pretty much done there at that point. Now the server over here is sitting there looping around, and if it equals final, right, then it go ahead and says, okay, we're going to we're closing the socket connection. So it writes to the output final acknowledge, right, and then it breaks, and breaks causes it to loop out of the while statement and print closing socket, which actually closes up the socket. And then it goes back around, of course, into its main while loop and sits here at socket accept. Okay? So you can see it received the final, and then it sent final acknowledge, and then it went ahead and closed the socket, and now it's listening on port 4141 again. Okay? And coming back over here to the client end here, right? It received the final acknowledge, right? And all it went ahead and did is just it did a break. Okay, so you can see over here, right? It received the final acknowledge, that triggered closing socket and the termination of that program completely, which returned it back, of course, here to the DOS prompt where I typed in ipconfig. Okay, let's go do CLS to clear this off, right? This guy is still running over here, so I'm going to pump in some other numbers here, just random numbers. You know, obviously if it ends in a digit like that, the answer is composite there. You can see how quick our communications go there. So a prime number has to end in a 1, a 3, a 7, or a 9, right? If it's an even number, ends in an even number, you know, 0, 2, 4, 6, 8, it's going to be a composite because those are all divisible by 2. If it ends in a 5, it'll be divisible by 5. So let's just start off with this and add a 1 to it there. So that one's composite. It's divisible by something. 3, right? Prime. So that one's prime. And let's put a 7 on the end. Oops, that did an 8. There we go. 7 on the end. That one's prime. And let's try a 9. And that one's a composite number too. You can even modify the program to return back, you know, what it was first divisible by for these composite numbers if you wanted to. But anyway, so that's basically about how that works there. Throwing in some garbage there, like if you do something like this, it's just going to come back invalid number, no program crash or anything like that. If we throw in a, well, you know, I don't know. Let's see what happens with a -1 number. I didn't test that. No prime, so that might be a little bug with my program there. Negative numbers are always coming back prime, which is not the case. So there's a little bug in my program. I hadn't tested that going into this video, but anyway, so throwing in a little errata there is the prime calculation will only work for positive numbers, and I'd have to put a little catch in there to check and see, you know, basically if the number is less than 1, right? Go ahead and break out there, right? So let's just go ahead and do that. I'm just a perfectionist. If I is less than 0, you know what? Yeah. If I is less than 0, let's do less than 1. I'm just going to my tabs aren't necessarily. Let's line this up a little better here. And then I'm just going to return And I'm just going to do the invalid number must be positive. All right, I think that looks pretty good there. I don't know why I did that. That's much better there. Okay, let's save that. We'll just come back over here, do a Control-C to kill our thing, Java, and run it again. And now let's make sure our negatives, invalid number must be positive, so that looks good. Also, since it's an integer, right, we can overflow this value coming in there too, and that's going to say invalid number 2 as well. You know, so let's see, we can go up, let's keep adding digits until we overflow it, invalid number. So I think it's somewhere around 4 something. But anyway, you guys get the idea there. It's obviously just a program more designed to introduce you guys to socket communications as opposed to being bulletproof, which you want to make sure your actual real live programs account for a lot more than I have here. But anyway, I think I'm going to just go ahead and close out of that, close out of that, or minimize that, and that, and that. And that pretty much concludes this tutorial. No real final thoughts on this one. Thanks for watching.